Titan, a name that stirs the imagination. Saturn's largest moon, with an atmosphere thick and mysterious, shrouded in haze. For centuries, humanity has looked up at the stars, asking what lies beyond our world. What alien worlds could offer clues to our origins, to the history of the solar system itself? Of all the moons in our solar system, none hold as many secrets as Titan. It's a world so alien, so unlike anything we know, that it almost feels as though it comes from another time. A time when our own Earth was just beginning to form, when oceans were still young and the air thick with gases, full of the ingredients that could lead to life. And yet, Titan is more than a world frozen in time. Beneath its thick, nitrogen-rich atmosphere lies a landscape unlike anything we've ever seen. A land shaped not by water, but by methane and ethane. Here, rivers of liquid methane carve across icy plains, and lakes the size of oceans shimmer on a cold, orange-hued surface. To some, it might seem uninhabitable, even inhospitable. Yet Titan holds one of the greatest promises in space exploration. Could it hold the key to understanding life's origins? Could it be a window into the early history of Earth, or even the potential for life beyond our planet? For the longest time, our only view of Titan was from afar, with distant spacecraft like Voyager and Cassini giving us glimpses of its surface, sending back tantalizing images of a world that beckoned but remained out of reach. But now, we stand on the edge of a new chapter in space exploration. Thanks to a groundbreaking mission, NASA is poised to finally land on Titan, and not just land, explore. This is not just a lander that will touch down and stay put. This is Dragonfly, a revolutionary rotorcraft that will take to the skies of Titan, exploring vast stretches of its surface, unlocking its secrets one flight at a time. In 2027, Dragonfly will begin its 7-year journey from Earth. Unlike a typical spacecraft that would merely coast through the vastness of space, Dragonfly is special. It's a flying laboratory, a versatile quadcopter capable of taking to Titan's thick skies to investigate its surface from the air. With Titan's dense atmosphere, it will be able to soar, powered by 4 rotors, much like a drone on Earth. But make no mistake, this is no ordinary drone. Dragonfly is designed to perform complex scientific experiments, traveling to some of the most remote and fascinating locations on Titan's surface. It will be the first rotorcraft to explore another world, a landmark moment in human exploration. Getting to Titan is no small feat. Titan lies over 1 billion kilometers away, beyond the orbit of Saturn. Reaching it requires intricate planning, fuel efficiency, and the strategic use of gravity assists, utilizing the gravitational forces of other planets to guide Dragonfly through the immense distance. When it launches, Dragonfly will embark on a journey so vast. Its arrival on Titan will feel like the completion of an epic quest, a journey of patience, determination, and vision. After years of traveling through the cold depths of space, Dragonfly will finally approach its destination. Titan's atmosphere is dense, a shield of gases that will both help and hinder the mission. As Dragonfly enters, it will face the first of many challenges. Unlike Mars, Titan's thick atmosphere is a mixture of nitrogen and methane, which presents both an advantage and a challenge. It will allow Dragonfly to fly, but it also means the spacecraft has to contend with greater atmospheric pressure than we experience on Earth. In order to protect the craft from the extreme cold and hazardous conditions, Dragonfly will be equipped with a specially designed heat shield. This shield will ensure that Dragonfly survives the intense conditions as it enters Titan's frigid atmosphere. As Dragonfly descends toward Titan's surface, the real magic begins. The spacecraft will deploy a parachute to slow its descent, allowing for a gentle landing. Titan's surface is not just an icy wasteland. It is a landscape teeming with complex features shaped by chemical interactions we can barely understand. Once Dragonfly lands, it will deploy its 4 rotors, lifting off and exploring the ground beneath it like no spacecraft has done before. This ability to fly makes Dragonfly truly unique. While most landers are confined to a single location, Dragonfly will be able to roam across the surface of Titan, covering vast distances and encountering a variety of geological features: liquid methane lakes, icy mountain ranges, and frozen seas. Imagine an aircraft capable of flying over Titan's frozen plains, skimming over the surface of its methane lakes, and swooping over towering icy mountains to get a clearer picture of this alien world. As it explores Titan's surface, Dragonfly will study the composition of its lakes, rivers, and icy plains, regions where liquid methane and ethane flow across the surface. Its scientific instruments will allow us to peer into Titan's chemical processes in ways never before possible. By studying the molecules in the air, the organic compounds on the ground, and the icy mountains, Dragonfly will give us unprecedented insights into Titan's weather, its atmospheric conditions, and its complex organic chemistry. Could the ingredients for life be present in these cold, distant lakes? It's a question Dragonfly aims to answer. But Dragonfly's work doesn't stop there. By using spectrometers and imaging devices, it will analyze Titan's surface in intricate detail, allowing scientists to reconstruct a picture of the Moon's geological and atmospheric history. What we learn could hold clues to the formation of Earth itself, and maybe even the potential for life elsewhere in the universe. Could Titan, a world so distant from our own, be a prebiotic laboratory where the building blocks of life are created in the methane seas? While Dragonfly will spend most of its time soaring through the air, it will also make occasional landings to conduct detailed, close-up investigations. During these landings, Dragonfly will collect samples of Titan's surface and analyze them in its onboard laboratories. These samples will offer insights into Titan's icy geology and its potential for harboring the essential components of life. With every flight, Dragonfly will gather data from a diverse array of environments: icy plains, methane lakes, and mountainous terrain. By combining all of this data, we'll be able to create a comprehensive understanding of Titan's dynamic environment, from its winds and weather patterns to its organic chemistry. Back on Earth, scientists at NASA's Mission Control will be receiving this data, analyzing every bit of information Dragonfly sends back. Each image, each sample, each reading will help build a clearer picture of Titan's past and present. And with every discovery, we'll move closer to answering one of the most profound questions in science. Can life exist in places far beyond Earth? The data Dragonfly sends back will also have profound implications for our understanding of how organic compounds form and evolve. Titan could be an ancient, frozen version of early Earth, where complex organic molecules formed long before life as we know it ever appeared. What if Titan's lakes and seas are the remains of a primeval chemical laboratory, preserving evidence of how life could begin in the cold reaches of space? As Dragonfly flies over Titan's surface, it's not just mapping out the terrain. It's charting the history of the solar system. In Titan's frozen lakes and icy mountains, we see echoes of the ancient, primordial processes that shaped our own world. In the methane clouds swirling above, we see a world with the building blocks of life. Titan is more than just a destination. It's a time capsule, a link to the past that could help us understand not only the formation of our own planet, but the possibility of life across the cosmos. The journey to Titan is not just a technological triumph. It's a voyage of human curiosity, of exploration and discovery. It reminds us that the universe is vast, mysterious, and full of wonders waiting to be uncovered.